Hey Panthers! We are continuing to look at section 12.1, two-step equations, and this lesson is going to focus more on story problems and how to write a two-step equation that represents a story problem. So please have your notes in front of you and your calculator, and we will go through the examples together. Before we begin, at the top of your notes today, you have a chart of some information about numerical expressions and algebraic expressions. This is back from my I think section 1.4, chapter 1, section 4 that we did at the beginning of the year, where we tried to take words and write them using addition, subtraction, multiplication, division signs and numbers. So this is just a good reference for you and a good reminder about looking for keywords in story problems and how to write them out within an equation. So, I know we keep talking about story problems. Again, today I want you to continue. Please, if you have a highlighter, get your highlighters out. We're going to highlight important information. If you don't have a highlighter, you can go to underline. But the important thing is to pull out key information from the story problem and create an equation to solve. So, let's begin. Let's take a look at example 1. A convenience store sells an insulated soda cup for $5.95. Each refill costs $1.10. Last month, Kit spent $27.95 on a mug and refills. How many refills did she buy? Panthers, here's what I want you to do first. First, find the question that you have to answer. Usually is the last one. How many refills did she buy? What are we trying to solve here? Or what do we not know? We're trying to figure out how many refills there are. Okay. So, if I'm solving for refills and I don't know what my answer is, we need to choose a variable. What would be a good variable for refills? Again, we talked about choosing a lowercase letter with whatever it begins with. So I'm going to choose R. Now obviously in my equation I'm going to be using the letter R as my variable. Now let's go back and pull out the key information here. A convenience store sells an insulated soda cup for $5.95. One thing I want you to think about when you're doing these problems is if what you're talking about is something that occurs one time, or is it something that occurs often? For something that occurs one time, it would be associated with a addition or multiplication problem. If it's something that occurs multiple times, you're going to want to consider multiplication or division. Okay, so they sell an insulated cup for $5.95. Think to yourself, is $5.95 something you're going to pay one time, or is it something you have to pay over and over and over again? Typically, gas stations these days, you can buy a cup one time and you can refill it. It doesn't mean you have to buy an insulated cup every time you go into the gas station. You pay $5.95 one time. Okay? Now, on top of that, each refill, are refills something that happen once or they happen many times? Refills are something that happens many times, so this is going to be associated probably with a multiplication step. So if refills cost $1.10, so again, thinking about this, if I only refill it once, it's $1.10 times 1. If I refill it 50 times, it's $1.10 times 50. So whatever we do with 110, it's going to be a multiplication problem. In other words, you take $1.10 and you multiply it by the number of refills that you take. Okay, so again, we just figured that out. Now last month, Kit spent $27.95 on a mug, so she only bought one mug, and refills, but we don't know how many refills that are. In other words, she had to buy a mug for $5.95, and in addition, there was costs with each refill. So we take the cost of each refill and multiply it by the number of refills that we actually took. And what we do know is that Kit spent a total of $27.95. Okay, so there's your two-step equation. Okay. Going to draw your line down both sides. Again, inverse of any addition or subtraction first. Here, 110 is being multiplied by r, and again, remember the signs in front. So this is a multiplication step. Here we have a positive $5.95. So what you need to do is undo this first, subtract $5.95 from both sides. These cancel out. We're left with 1 10/100 r equals $22. Okay, and now we need to solve for our variable of r. So since r is being multiplied by 110, we need to divide by $1.10. Grab your calculators, divide both sides by 1 2/10, and you see that r equals, whoops, not dollars. Remember what we're talking about. What's our variable? R is 20 refills. So we know that Kit bought a mug for $5.95. She refilled it 20 times and spent a total of $27.95. Let's try another one. A mobile phone company charges $15 for the first 25 text messages and then 59 cents for each additional message. Last month, Michael spent $59.25 on text messages. I'm thinking some of you probably, this sounds familiar. How many text messages did he pay extra for? Oh, my goodness. Okay, so a couple of things here. Let's start with our question. How many text messages did he pay extra for? We're trying to find out about text messages. We don't know the answer for the number of messages. We do know this is going to be our units for our answer. So since we don't know the answer, let's go ahead and use the variable m. So a mobile phone company charges $15 for the first 25 text messages. So thinking again, that is a one-time amount. You create 25 text messages, you are going to have to pay $15 for them. But on top of that, in addition to that, he also has to pay 59 cents for each additional message. Again, thinking if he only sends one additional message, it's only going to be 59 cents more. But if he sends 100 additional text messages, it'd be 59 cents times 100. So we have to take the cost of each text message and multiply it by the number of text messages we're actually sending. So there's the second part of our equation. We have our $15 cost for the first 25 text messages. In addition to that, we also have to pay 59 cents for each text message. We know Michael spent a total of $59.95. $4.25. So let's go and see how many text messages, additional text messages above the 25 that he actually sent. Again, on the left hand side is my variable m. M is being multiplied by a positive 59 hundredths. We also have this 15 over here. 15 is positive, so let's go ahead and do the inverse of that, which would be to subtract 15 from both sides. Once I subtract 15, my inverse operations cancel out, and we're left with 59 hundredths multiplied by m. And on this side, we need to take our $59.25 and subtract the $15 out, and we get $44.25. Okay, so again, this doesn't answer a question. We got to get m alone. In order to get m alone, we divide both sides by 59 hundredths. Grab your calculators, and we find that m is 75. 75 what? Think about what your variable represents. 75 messages. Okay, there's your answer. Next one. If you double the number of calories per day that the U.S. Department of Agriculture recommends for children who are 1 to 3 years old, and then subtract 100, you get the number of calories per day recommended for teenage boys. Whew, a lot of information there. Given that 2,500 calories are recommended for teenage boys, how many calories, here's our question, how many calories per day are recommended for children? Okay, how many what? Calories. So we are going to use C as our variable, since C is what we are going to be solving for. And again, keeping in mind that we know the amount of calories for teenage boys. This is calories for children. A lot of information here, okay? Let's go back through the problem. If you double, what does double mean to do? Multiply by 2. If you double the number of calories that the U.S. Department of Agriculture recommends for children, okay, if you double the number of calories for children, okay, and then subtract 100, you get 2,500. See, I got rid of all that garbage. If you double the number of calories for children and then subtract 100, you get the number of calories for teenage boys. You get 2,500. So let's write that up. If you double or multiply the number of calories by 2 for children and then subtract 100, you get 2,500. Okay, there's our equation. Let's go ahead and solve it. Again, here C is being multiplied, and we have a minus 100 or a negative 100, so we're going to add 100 to both sides. We are left with 2C, and 2,500 plus 100 is 2,600. C is being multiplied by 2, so we divide both sides by 2, and we get C equals 1,300. What does C stand for again? 1,300 calories. So, children ages 1 to 3 are recommended to eat 1,300 calories per day. I don't know if that's true, but we did a math problem on it. As always, Panthers, you may want to put your pencil down now and re-watch this, but go ahead and please complete the try-it problems. Actually, I don't think there are any try-it problems. So, bring your notes with you to class tomorrow with your calculator, and we will be good. Have a good night.